Hello everyone, I'm Liu Rujia, the product manager of SMTX. I'm very happy to share that we recently released SMTX Kubernetes Service 1.0.0. Next is a product demo of SKS. First, this demo includes 3 parts. The first part is planning and preparation before use. The second part is how to install and deploy SKS. And the third part is formal use, including resource creation and management, as well as daily operation and maintenance operations. Planning is required before using SKS. First, IP planning. The following objects need to be configured for IP in SKS: image registry, management cluster, and workload cluster. Before use, you need to calculate the required number of IPs according to actual needs and reserve them in advance. Then choose CSI and CNI. For CSI, SKS currently supports 2 self-developed solutions: SMTX ELF CSI and SMTX CBS CSI. For performance and ease of use, we recommend using SMTX ELF CSI. For CNI, we currently support Calico and ECP. They each have their own characteristics, and users can choose according to their actual needs. Next, I will demonstrate the deployment and use process through actual operation. First, you need to deploy the image registry before deploying the service. The image registry is used to store and manage all container images used by SKS, including component container images, Kubernetes component container images, etc. The SKS image registry runs in a virtual machine in the SMTX OS cluster. When deploying SKS, the system can automatically pull images from the registry. After the image registry is deployed successfully, you can continue to deploy the SKS service. According to the usage requirements in different scenarios, users can choose a suitable deployment mode. SKS uses IP pools to uniformly allocate and manage static IP resources. There are 2 types of IP pools: management cluster IP pools and workload cluster IP pools. The management cluster and workload cluster can obtain IPs from them respectively. After the SKS service is deployed, the system will create a SKS management cluster. The SKS core service runs in the management cluster and provides functions such as cluster management and plugin management. After the SKS service is deployed, the system will create a SKS management cluster. The SKS core service runs in the management cluster and provides functions such as cluster management and plugin management. In the life cycle of the workload cluster, there are many scenarios where nodes are dynamically created. In order to solve the problem of automatically configuring static IPs, the IP pool function is provided. The workload cluster is a Kubernetes cluster used to run business workloads. You can create workload clusters with appropriate resource specifications according to actual needs, and choose appropriate CSI and CNI according to actual needs. This demonstration will create a workload cluster using SMTX LCSI and Calico. If you want to use a static IP, you can choose the workload cluster IP pool we created in the previous step. So the IP pool will automatically assign a static IP to the business NIC of each node. In the list of workload clusters, you can view all workload clusters. In the overview interface, you can view detailed information of the workload cluster, including resource usage, cluster component status, node role and quantity, Kubernetes version and control plane virtual IP, cluster events and creation time, etc. The kubeconfig file contains the access address and authentication credentials required to access the workload cluster. It can be used in combination with the kubectl command line tool or other clients. You can scale the workload cluster by editing the number of existing worker node groups or creating new node groups. If there is already a node group that meets the configuration requirements, you can directly edit its number of nodes. If you need other configuration nodes, you can create a new node group. There are two ways to create persistent volumes, dynamically and statically. Dynamic creation refers to indirectly creating the required persistent volumes by creating persistent volume claims. This method must use storage classes. Static creation refers to preparing persistent volumes in advance and then binding and using them with persistent volume claims. SKS currently supports dynamic creation. You can manually manage log, monitoring, load balancer, ingress for workload clusters. SKS integrates MetaLB and Contour to provide external access capabilities for services within the workload clusters. You first need to enable log function in the add-on management interface of the workload cluster. And then you can view logs of different types and different time periods of the log pages. Monitoring also needs to be enabled in the add-on management interface of the workload cluster. Then you can view monitoring information of different charts and different time periods on the monitoring page. When you need to upgrade the workload cluster, first you need to upload the node template corresponding to the required Kubernetes version to the SMTX OS cluster where the workload cluster is located. When a node file with a higher Kubernetes version is available, you can upgrade the workload cluster. In the management cluster, you can view relevant information about the management cluster and the cluster nodes, such as the Kubernetes version of the management cluster, the deployment mode, resource usage and basic information, status, and the resource usage of nodes, etc. The demo of SKS ends here. You can learn more information on our official website, official accounts, and other platforms. Thank you for watching.